Hello, let's solve some Leetcode today. And first task we have maximum prime difference. You're given an integer array nums. Return the integer that is maximum distance between the indices of two, not necessarily different prime numbers in nums. Okay, so first we have to calculate how we're gonna decide if prime number is prime. Right, so number is prime number, the sum is at least 1. Explanation is because it's just 1 prime. Nums to 0, 1, 2. So 2 is prime. Right, 1, 3, and 4 are prime. 0, 1, 2, 3, and 4 are prime. So answer everything 4 and 1. Okay, so first let's define function is prime. And it is number, and it will return something we don't know. So the code we should build as follows. So we first we assume that maximum difference is this and this, right? This is maximum distance. So we start left pointer here, right pointer here, and we check if they're prime. If they're not prime, we move forward. Right? We move them closer to the center if letters are not prime. This is this prime, right? And this not. We move again, and they're two primes. And we say that 3 is prime, so we leave it here. So 0, 1, 2, 3, 4, and the answer distance will be 3. This is the max distance. So we define left and right, which is 0 nums, and we can say y left less than right, and if nums, we can say is prime left and is prime right. We immediately return right minus left. Then, if left is prime, if not left is prime, we increase left. If not right is prime, we decrease right. And I don't know, if we found nothing, we just return -1, probably. It said that they're always there 9 primes, right? So let's go back to this prime function. So prime is so if number is so 0, 1 are not primes. So if number more than 1 then we have to check, else we return false immediately. Then for checking, we check for e in range between between 2 and divided by 2. And if residual from dividing is 0, so if n divided by I equals 0, it's not prime, we return false. All right? And here, after we checked everything and it's not, we return true. Okay, let's check. It's looking good. Invalid decimal editor for len nums. Oh yeah, typo. So yes, missing semicolons. So this is returning true. This is not. Question is why? Because 2 is prime. And yeah, this is 0, right? Did we reach 2 and 2? Why output is... Why we have this output? So we set left and right here. We start removing here. This is prime. Left is not prime, so we're moving left here. Moving left. Expected 0. Why it's 0? Because there is just one prime in number and answer is 0. So we just return 0, but why we are returning true? Returning right minus left. Okay, so let's print left, right, left and right. So 0, 1, 2, 3, and 4 is prime. What? Oh yeah, it's okay. So if prime nums. So let's do this. Let's mark it as index I, and then number is nums I. Obvious. It's very funny. Out of range. So So let's define L, which is len-noms, and then we start from -1. So for 2, 5, 3, number 4, and nums 0. Why it's saying nums 0 is prime? So 4 and 2, 4 is prime. Oh, it's not counting the last one. Yep. Should count the last one. Now it's working. Let's see. Yep, 83%, which is good. Yeah, function is prime. Restart from the back. If it's prime, if x is prime. Oh, it's sqrt plus 1. From 2 to sqrt plus 1. Can I do sqrt 2? Not dividing by 2, but sqrt of n plus 1. And getting in from that. Yes, sqrt working much faster. Yeah. This is nice. Right. Should we have another one? Maybe 5 consecutive integers that soon given number. Just a second. Let's see. How is my submission? Not in front of us. Given an integer num, return 3 consecutive integers as a sorted array that sum to num. If num cannot be expressed and the num of 3 consecutive integers, return empty array. Alright, so this trial can be added 10 plus 11 plus 2. So there is no way. Okay, so what we can say if length of num, we can calculate length of num, right? Like here, if array is smaller than 3, L less than 3, we return empty array right away. We can define result as this, return result. Then for I in range started from 3 to L with right from 3 to L minus 1. What we have to do, we check 3 consecutive elements. If L, we can do running sum, but I don't know if we have to. So if given integer now, look at second number, that not sum to none. Okay. Oh, okay, I know what it. So it's not like this. We have to invent 3 consecutive numbers. So how would I approach it? So yeah, first is brute force approach. So what we're gonna do? We're gonna for in 10, 15. Okay. So how about that? Like just assumption. If we delete num by 3, right? We got average number, right? Then meaning average plus average plus average equal num, or average minus 1. So we got this. So average minus 1, average plus 1 and average. Is this going to be 3 consecutive numbers? Yes, it is. So then what we're going to do, we go on average divided by 3. If average plus 1 equal none, we return list with these guys. Else we return empty. So 33. Oh wow, it worked. Oh wow, 100%! Yay! I really like it. This is very fun to solve. Did anybody do it better? Yeah, same. Oh, it's kind of easier, faster than me, but yeah, still 100. Very nice. All right, let's solve another one. Rotate list. This is going to be fun. So given a head of linked list, rotate the list to the right k places. So k2, we rotate. Rotation means we put 5 on top, then we put 4 on top. So what we can do first, we could calculate length of the list. So length of the list, because we have to move to the end position anyway. All right. And I will do sentinel node. So I will just keep so L equals 0, we position to the end. So head and we assign sentinel next to head, then while head we can say head equal head next, reassign tail to head. So problem is that if we have to reassign k as mode of L, because if we have extremely large k, we can just skip full rotations, right? Then we perform rotation. So we have tail as a least node pointing to head here. Can we do minus NF? Okay, head. So we have 2 pointers. Now we have 2 pointers. One pointing to the tail, and one pointing to the head. So this is head sentinel, and this is tail sentinel. So what we're gonna do? We gonna, but this is single link list. So we have to go all the way from the left to the right, find to the last one, and then rotate it to the head again. And go to the last one and rotate it to the head. To the last one and move it to the head, and so on. But this is not very efficient. I wonder if we can come with a better solution. Okay, maybe better solution will be have 2 pointers. 2 pointers, and as they go through the list, let's call the solution B. Let's comment this. So this is solution A. We rotate as we go. Solution B, we have 2 pointers. First fast is going over to the right, all the way to the end. Second, slow, and slow waits for n for k cycles of fast. Then it fires, it starts moving after that. So we're gonna have this pointing on 4, and fast will be pointing to the end. So this will be slow, this will be fast, right? By 2. 0, 1, 2, 3, 4. So this one 0, 1, 2. 4 minus 3. Yeah, 4 is so it will be 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Like this. So this will be pointing to 4, this will be pointing to 2. Right? Then, second step. So first step, we stop at this position. F will be, and S will be on F minus K position. Then what we're gonna do, we're gonna assign X next to none, S next to we have a new beginning node equal S next. Then we assign X next to none. Then we take beginning node next, we assign to head. No, not beginning node, but F node next, we assign to head. And we return beginning node. In this case, we're gonna have this goes here, right? Yeah. But I would leave this code calculate length and mod it, because otherwise it will be mess. So let's say the plan plans which accept head or like no. And what we're gonna do, we're gonna say without changing node, so we assign some running node to node, and then while running node we increase L, and we move run node, and we return two values. First we return running node, and then we return length. So here we shouldn't I do without a function? Okay, yeah, let's do it without the function. So I will assign current node to head, and do this magic to the current node. Then I reassign k. Now my current pointing to the end. And here is also what I'm gonna do. I'm gonna introduce running lengths, which is k. And I have, so let's call this fast and call this slow. They both pointing to head, while fast, we are moving fast. And also, we have to move slow, but only if running length is equal 0, we move slow, right? Else, we decrease running length by 1. So in this case, our slow will start after fast. Fast will go through k and then slow start. And at the end, we have this position showing fast and slow. But we have to calculate length first. So this sounds like second pass anyway. Okay. So let's calculate length first. Then we calculate k. So is this, maybe there is a condition that k is, no. K can be large. So we have to calculate this k. All right, then we do this again. But this time we we're gonna have two fast and slow pointers, and fast is pointing to the end. But in this case, at this point, we're gonna have this shown, right? So we have to do this. So we have some beginning pointing on x next, s next. We point to 1, none, then f next we point to head, and we return b. integer modulo by 0. Length is 0. That's y. Okay. Yeah, missing important character. Okay, access to variable regular is not associated with the value. Run length is equal to and run length is equal k. Here we do f next is none. So f okay, so we probably pointing on f is pointing on none. We have to catch f. Let's say while f next. Nice. So if list is 0, then we return 0. All right. If L is 0, we return head. Is less than 2. So 0 and 1 we return head. Use that case. So 0, 1. Oh, 0, 1 is 2, so rotation is still possible. Less than 1. Why is that? 1, 2. Wait. Use this case. So I can say if L or k equals 0, we return head. So I can say if out more than 0, so many corner cases. Yay, 100%, yay, success. Yeah, I really like this solution because I didn't do brute force, and brute force is kind of not good because it's we could be rotating for like very large amount of cycles rather than we just calculate. It did we used modulus, so we moved just only that cycle we moved on that specific shift inside the list, not like doing all this crazy rotations all the time. Oh yeah, very nice. I like it. Oh yeah, that will be it for today. Thank you for watching and see you next time. Bye.